two words are anagrams if one is just a rearrangement of the other's letters. The obvious way to check that is to sort both words and compare them. It works, but it is not actually the fastest option available. And today, we build the faster one. Here is the setup. You get two strings, S and T, and you return true if T is an anagram of S. That means every letter in S has to appear in T exactly the same number of times. Nothing more, nothing less. If the two strings are not the same length, you can rule it out immediately without checking a single letter. The most natural first idea is sorting. If you sort both strings alphabetically, two anagrams will always produce the exact same sorted result, since they contain the same letters, just rearranged. It is a clean two-line solution. The catch is that sorting is not free, and on longer strings that cost starts to matter. We check lengths first, since mismatched lengths can never be anagrams. Then, we sort both strings and compare them directly. If the sorted versions match, every letter appeared the same number of times in both. This is correct and readable, but sorting takes n log n time, and we can actually do better than that. Sorting costs n log n time, because comparison-based sorting can never go faster than that. But we do not actually need the letters in order. We only need their counts. Counting each letter as we scan through both strings brings us down to linear time for roughly the same memory cost. Instead of rearranging letters, we count them. As we scan through S, we build up a count for every letter we see. A appears, so its count goes to 1. N appears, its count goes to 1. A appears again, so its count climbs to 2. Once we have counted all of S, we do the same scan over T, and every matching letter in T just cancels out one of those counts. Python's counter class builds exactly the letter count dictionary we just traced through in a single line. We check lengths first, as before, then build a counter for each string and compare them directly. If the counts match exactly, the strings are anagrams, and we get there in linear time instead of n log n. Let's check it with anagram and nagram. Both strings are 7 letters long, so we continue. Counting S gives us 3 A's and 1 each of N, G, R, and M. Counting T gives us the exact same breakdown, just built from a different order of letters. Since every count matches, we return true. Whenever order does not matter, but frequency does, counting almost always beats sorting. It is a small shift in thinking that saves real time on larger inputs. Next episode, we look at toSum, the classic problem that made this exact hash map trick famous in the first place. Subscribe so you do not miss it. See you in the next one.